Oh, no, 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 no. Let's remove this stuff over here. What the heck? Now what? Fire trucks? They're not for me, but what are the odds that they show up while I was brazing and smoke came out? Today I will show you how to repair refrigerant leaks for AC system and refrigeration systems. The first step is to find the leak, recover refrigerant, repair the leak, check if the leak is repaired, evacuate the system, refill the system, and then do a lot of tests. Now, there is no one size that fits all. Every system is different, and there are certain precautions that need to be made for each and every situation. Oil leaks out with the refrigerant all the time. So when you braze or solder, be prepared for the system to catch fire. I was very prepared. I had water on the side, and the funny part was while I was brazing and the system caught fire, the fire truck came in and I knew it wasn't me. So I just thought it was humorous to add that to the video. The repair took over 5 hours. Yes, you heard that right. It took over 5 hours to fix the refrigerant leak. I had no choice. Brand new evaporator is very expensive, and there is about 2 weeks lead time. So the customer decided to go with the repair. And just for clarification, you need to be EPA Section 608 certified in order to be able to handle refrigerant. Now, this video is tailored in particular to my HVAC students and to bridge the gap between theory, practice, and what we deal with in real world. I also want to show how to distinguish between nitrogen usage. So when brazing, we need to flow nitrogen. That's completely different from when testing for leaks. When we test for leak, we need to pressurize the system and keep it pressurized for, I would say about 20 minutes. It depends on the pressure. Each system is different, and those values should be written on the nameplate. Also, I will show the evacuation procedure. In my case, the system held way below 500 microns for over 20 minutes. I'd really appreciate your feedback on the content and procedure. Hope you enjoy the video. Now let's get into it. This RTU is not cooling. Let's open up and check it out. Let's see if we see any error code. Idle. Okay, locked out due to low pressure. So error code means either we low on refrigerant, bad sensor, or probably a bad PCB. I'm gonna check if the thermostat is calling. Okay, 26 volts. Yeah, we have a call. I gauged up. We started the system. Compressor started. Looks like we're going down on pressure. Seems like the pressure is low. Probably have a leak. Oh wow, 49 psi for 410A. We're very low on charge, very low. We definitely have a leak. Let's shut the power off. This disconnect is missing the cover plate. What's that? This disconnect is severely damaged. We have to replace it. I gotta tell the customer about it. It overheated. It's no good. Time for Mission Impossible. Gotta find the leak. Alright, let me open up this side here. That's gonna be hassle. Alright. Now I'm here, I'm gonna check the filters. I'm gonna check the belt. As much as I could see. Feels tight. So I noticed traces of oil. I pulled my leak detector. I'm using the Infocon Detect 3. Good for me. I found leaks with it. Traces of oil all over the place. Traces of oil are almost in the middle of the U-banks. Usually I start from the top because refrigerant is heavier than air, so it settles on the bottom. So let me find the general area and then I will pinpoint. There we go. I found you. There we go. Second hit. Same spot. And now we're all over the place. That's gonna be frustrating. I know it's here. I'm restarting from the top. going all the way down, but I think it's in the middle, somewhere in the middle. That U-bend looks suspicious, very suspicious. I hope the leak is not behind the fins. Just hoping. Now, why on earth am I getting a hit on the top? Why? I don't see oil. I think I'm gonna bubble up. Soap and water is the solution. That's it. Okay, the system started with about 150 psi. Good enough to soap bubble, find leaks. Low tech, but it works. It really works. It's literally the confirmation. The detectors lie. Soap bubble never. This is critical step. You gotta wait. You have to be patient. You need to see the bubbles growing. Very important. Very, very important. What the hell? I think I see something. I saw it. That's it. That's it. Second time here. There we go. There we go. Guaranteed now. Trying to zoom in. Pay attention. Bubbles are growing. Not bubbles, they're bubbles that are growing. Important. Awesome view. Awesome. Awesome footage. Now that we found the leak, there are some other steps. First, we need to recover the refrigerant. In order to do that, I need to prepare the recovery tank and recover the refrigerant. Then flow nitrogen from one side of the system to the other side, because I'm brazing, not soldering. Then braze the system, and after that, we have to repressurize the system in order to check if the system has been properly sealed or not. If the system is properly sealed, then after that we have to evacuate the system, and then we could refill the system with refrigerant. Okay, as you could see, I'm preparing the recovery tank. That looks like 300 microns. I'm good. Not wasting my time. There is a lot of oil. When I started brazing, it caught fire. First time, second time. So I decided to clean the system a little bit. Probably doing way too much, but it is what it is. I'm adjusting the nitrogen pressure. I set it on the brazing mode, so it's very low pressure. I think it's between 3 to 5 psi. Now, if you want to buy a flow meter, that's your decision. It's probably highly recommended to buy a flow meter and to work with that. Okay, I'm using acetylene only. You could use oxyacetylene. Really depends what you're doing. You could use MAP gas. Okay, I have to focus when I brace, so I might be a little bit quiet for a few minutes. Notice I'm using a bottle of water, just in case. Now when I brace, I have to focus, so I have to be quiet for a few minutes. Okay, I don't care about the look of the brace. I just want to make sure that there is no leak. It looks like it needs a little bit more over here. Let's see if that works. So the nameplate calls for about 200 psi. So I pressurized the system to 200 psi. Not flowing nitrogen. I pressurized the system with nitrogen to 200 psi. Now I'm looking for leak. Double checking. I want to be specific. I put nitrogen with some traces of R4 Make sure that the leak detector could detect it. Alright, I changed the settings to sensitive mode. That takes a while every time. It's not trivial. No way. Did I miss? What the? I mean, you've got to be kidding me. Again? Same spot? I think I have to saw bubble it again. Hold on. I put it at 200 psi. I'm confused. I'm frustrated. I'm at a loss here. Yep, guessed right. Gonna sit down and make myself comfortable. I need to find the leak. Huh. Same spot. You got to be kidding me. Maybe it's in the fence. Nope. It looks it's right here. Is it in the coils? I don't want to take out those pins. Let me check. I mean, at this point, I'm beyond pissed. It doesn't look like it. I think it's the U-bend again. It's the U-bend. Did I miss? some soap bubbles again. Now I gotta wait. What, 5-10 minutes again? This is beyond frustrating. Thank God. Have patience. I see something. Hold on. Think I got it. It's different one. Let me try to zoom into that one. I see it. Here we go. It's right at the interface. Oh my God. How am I supposed to brace that one? Alright. Let me try to give you a better view. Just gonna give it a shot. Let me zoom in. I see it. It's right there. It's a volcano. As shown in the footage, I have to redo a lot of steps. Again, release pressure, flow nitrogen, brace, pressurize the system, and test for leak again. Just to give you heads up, I'm flowing nitrogen. I gotta find the right angle and right position in order to be able to brace. That's a difficult one. So the molten silphos has to melt and flow nicely. I'm hoping I don't have to cut the galvanized plate. It's gonna be a disaster if I do so. I've done it before, but I don't want to do it again. I'm gonna try to do it in one shot. If it doesn't work, it's gonna be very tough. Now I'm gonna pressurize the system to about 200 psi, and then check with the leak detector and the soap bubble, and I'm gonna run pressure test for about 20 minutes. Sometimes I do less, it depends. So I pressurize the system to about 200 psi. I'm using soap bubble first because I know the area, so I want to make sure that that area is fixed, and I will worry about the other spots if there is any. Many times we had systems with multiple leaks. I remember once we fixed a coil that had 7 leaks. The customer couldn't wait. The lead time was 2 or 3 months to even get an evaporator. So it was a walk-in cooler, so I couldn't wait. Customer cannot wait. In multiple times we had to fix coils that had multiple leaks. I mean, you have to deal with the problems. We are in the business of fixing problems. That's what we do. Troubleshooting and repair. I think we sealed the leak. And when I check the pressure test, let me see. What's that? That's about 10 minutes. The pressure hasn't changed. Let me zoom in. Passed. So let me summarize this. The pressure started at 197 and it ended at 195. It's temperature compensated test and the software does the calculation. So as you could see, it passed. It passed within 12 minutes. If I did not have temperature compensated test, I would wait for about 20 minutes, sometimes even longer. But in this case, it passed. And then I will run the evacuation procedure. And if the evacuation procedure passes, then I would be very comfortable that I fixed the leak. All right, now I'm starting the evacuation procedure. All right, let me see. 51,000. It's coming down fast. That's 190 microns. Excellent, excellent. I'm gonna close the gauges, shut the pump. If the system holds at 190, even slightly more, probably 250 for about 10 minutes, and we should be safe. Got distracted with the phone call. Let me see where we're at. What's that? 160. Perfect. So the industry recommends to hold 500 micron or below for 20 minutes. I was able to bring the system down to 160 micron, and I was able to hold 160 micron for over 25 minutes. We'll use that as another confirmation that we have no leak in the system. Refilling the system with refrigerant. So the system takes about 6 pounds and 6 ounces. I put about 4 pounds and then I started the system in order to be able to have the suction line bring in more refrigerant. And then I'm gonna meter the remaining, meter or throttle, whatever you wanna call it, the remaining refrigerant up until I get to certain metrics that I'm looking for. Alright, my superheat looks too high, so I'm still metering in until I get to what I need. So my subcooling might not be the most accurate one. There is no liquid port, so I'm using the discharge port to measure the subcooling. Now that gives me a clue. At least I know it's not zero, that it's not the correct definition of subcooling. The metrics look much better now, but still not good enough. I have to throttle a little bit at the time and then wait. It's a waiting game. You have to have a lot of patience in this industry. A lot of things could go wrong. Okay, it's much better now. It's getting dark. I need to start packing. It got dark. Finally, I got some help to help me pack. The system had enough time to stabilize. Values look so good. In this video, I showed how to find refrigerant leak in an AC system. Oil is byproduct of refrigerant leak, so caution must be taken when you braze. That oil might catch fire. I selected this footage because the oil caught fire while I was brazing, and I thought that's priceless footage to show. Now, I was lucky and I was prepared because I was brazing on a roof. A roof is not confined space like an attic or a basement, which are sometimes slightly more challenging to braze in as environments. With that, I hope you enjoyed this video. Feel free to comment. Any feedback is always welcomed. Thank you very much. See you in the next videos.